Hi guys, so today we're going to take a look at question 4 from the paper 1 of the 2016 exam. Alright, so we want to prove by induction that 8 to the n minus 1 is divisible by 7 for all natural numbers n. Okay, so straight away, the first step, what's a proof by induction? What does it mean to prove by induction? Well, we know that there are 3 steps. We know that the first step, and it's always good to get this down, is to prove initial case. The second step is to assume it's true for the kth case. Step 2, n equals 1. Assume for n equals k. And then the third step is to prove for n equals k plus 1 using your assumption. So we want to use our assumption that it's true for n equals k to then prove that it's true for k plus 1. So if it's true for some k, then it will always be true for the value after k. And so kind of you can think about the way that this will prove the whole thing. Well, if it's true for something, then it's true for the next value. And so we're going to prove it for the first value, and then it'll be true for the next value, which is just n equals 2. And then using that, it'll be true for the next value, which is n equals 3. And then you've just proved everything, because you'll just keep proving, use n equals 3 to show n equals 4, use n equals 4 to show n equals 5, and so on and so forth. So that's how a proof by induction will work. Now, what exactly is it that we want to prove here? And it's always important to specify this. We want to prove that 8 to the power of n minus 1 is divisible by 7. And so what does that mean? Well, it means that 8 to the n minus 1 over 7 is a whole number. Okay, so now let's follow the steps. So step 1, prove for n equals 1. Okay, well, let's let n be 1. 8 to the power of 1 minus 1 over 7. Well, this is just 8 minus 1 over 7, which is just 7 over 7, which is 1. And that's a natural number. Okay, and now what's our second step? Well, now we want to assume that it's true, assume that our proof is true for the kth value. So 8 to the k minus 1 over 7 is a natural number. It's a whole number. 8 to the k minus 1 is divisible by 7. Okay, and now finally our third step, step 3, is to prove that 8 to the k plus 1 minus 1 over 7 is a whole number. That's what we want to prove now. Now, before we get into this proof, I want to kind of bring to your attention, we actually haven't done any maths here. We haven't done any maths so far. We've just stated the definition of proof by induction. We've outlined what we want to prove, and then we've just done the very easy steps, step 1 and step 2. We haven't actually done any maths that's in any way difficult, but you know what? We've probably already gotten half the marks. Probably like 50 to 60% of the marks already. And so I really think I kind of want to take this as an opportunity to kind of drive home that before you get to the hard thinking, get the easy thinking out of the way. Get these easy marks down. Okay, so now we're going to move on to proving this. So, well, we want to start. Well, we have this 8 to the k plus 1, and we don't really like having a k plus 1 as an exponent. So we're going to use our rules of exponent, which is, so we have, if we have x to the m plus n, or let's just do this in blue because it's a rule, x to the m plus n, well, we can rewrite this as x to the m times x to the n. That's just one of our rules of exponent that we see in the log tables. So we can use this to write 8 to the k plus 1 as 8 to the k times 8 to the 1, which is just 8 by 8 to the k. Okay? And kind of the reason we want to have this term somewhere, because we're going to prove this using this. So we know we're going to need to have this term somewhere. So we want to get an 8 to the k. Okay. And we want to have, 1 times 8 to the k minus 1. So now, this is sort of the trick, the whole trick. So it might be difficult to think of, but these questions where you're showing that something is divisible they're actually not that uncommon, and it's the same trick every time. So you can kind of just be aware of it. So we actually are going to rewrite 8 times 8 to the k as 7 plus 1 by 8 to the k. Because of course 8 equals 7 plus 1. And now we're going to sub this back in, and we have 7 plus 1 times 8 to the k minus 1 all over 7. Okay. Well, now let's just multiply, let's get rid of the brackets. So we have 7 times 8 to the k plus 1 times 8 to the k minus 1 equals 7. And now, because we want to isolate this 8 to the k minus 1 over 7 term, we're going to split this fraction up into 7 times 8 to the k over 7 plus 8 to the k minus 1 over 7. Okay, and the whole thing that we're trying to prove is that this is a whole number. Well, we know that 8 to the k minus 1 is a whole number, so we know that, let's make this purple. We know that this is a whole number because, well, it's what we've assumed. That's what we've assumed in step 2. And, well, we actually know that this is a whole number as well, because you can just cancel the 7s, and then we've got 8 to the power of a natural number, which is, of course, a natural number also. So this is a whole number. So we've got a whole number plus another whole number, and this, of course, is going to give us a whole number. So a whole number plus whole number equals whole number. So if the first thing is, I don't know, 64, and the second thing is 35, 64 plus 35 is still going to be a whole number. Okay, and so now we've shown that this term, so 8 to the k plus 1 minus 1 over 7 is a whole number. And that's what we wanted to prove. And so we can finish this off. Let's just give ourselves some space. The way you finish off a proof by induction. So by induction, eight to the n minus 1 is divisible by 7. For all values n. For all whole values n. And that's our proof. Now on to part B. So given that log a of 2 is p and log a of 3 is q, where a is greater than 0, write each of the following terms in terms write each of the following in terms of p and q. Okay, so log a 8 over 3. So log a 8 over 3. Okay, and we know that log a of 2 equals p and log a of 3 equals q. So straight away we see a log, we go to our log tables and we go to the logarithm section. And we see that this rule, so log of let's say n to a over b is just log n of a minus log n of b. Okay, so well, let's use that rule. And to rewrite log a of 8 over 3 will be log a of 8 minus log a of 3. Well, we actually know what log a of 3 is. It's just q. Okay, so we'll use that later. And so we're going to use then another rule of logs. So log, let's just say log n of x to the, let's say, c. So x times some number. Well, you can actually just take the c out and you get c times log n of x. Okay, well, how does that help us? How might that help us here? Well, we know that 8 is 2 to the power of 3. So we know that 8 equals 2 cubed. So we can rewrite log a of 8 as log a of 2 cubed. And we know by our rule that this is 3 times log a of 2. And we actually know what log a of 2 is. Well, we have an expression for it. We know that it's p. And so kind of the trick to this question is getting it in terms of log a of 2 and log a of 3. Okay, so now we have 3 log a of 2. So log a of 8 over 3 is 3 log a of 2 minus log a of 3. And this is where we can finally sub in our expression. So this is 3p minus q. Okay. So now we've written it in terms of p and q. Now on to part 2, we want to write log a of 9e squared over 16 in terms of p and q. Okay, well, again, let's just write down what they're giving us. Log a of 9a squared over 16. And this is what we're trying to figure out what this is. Okay, well again, we know that log a of 2 is p, and log a of 3 is q. So again, we're going to try and write this expression that they've given us in terms of log a of 2 and log a of 3. Okay, so, well, we're going to use the same rule. Log n of a over b is, so when we have a fraction in a log, you straight away are going to be using this rule. So log n of a minus log n of b. So straight away use this rule. So that means that our log a of 9a squared over 16 is going to become log a of 9a squared minus log a of 16. Okay, well, let's work with this first term here, log a of 9a squared. Okay, well now when you have a product in a logarithm, you should immediately think of this rule. So log n of a times b is log n a plus log n b. Okay. Whenever you have a product, you should always try and think of this. So now that will mean that log a of 9a squared will be log a of 9 plus log a of a squared. Okay, well, we can again use this rule. So if log n, so whenever we see something that we know is a power, like a square number or a cube number in a log, we always try and think of this rule. So x to the c is just c times log n to the of x. And so since we can write n as 3 squared, so n equals 3 squared, we have, 9 equals 3 squared, we can use this rule to get log a of 9 equals log a of 3 squared equals 2 by log a of 3. And now we've gotten a log a of 3 term, which is what we're looking for because we know we have this expression here. Okay, and now what about log a of a squared? Log a of a squared. Well, now the easiest way to figure this out is, well, how is it that logs work? Well, log of your base term and then the thing in brackets is basically a question of the base to the power of what will equal the term in your brackets. So now we could write this as a to the power of what is a squared. Well, obviously, it's a to the power of 2 equals a squared. So a to the power of 2 equals a squared. This is just very obvious. And so this log a of a squared is, of course, just 2. A to the what equals a squared. A to the 2 equals a squared. Okay? So now we have this, and it's just a constant. And now finally, we're going to take a look at this term, log a of the 16. And now we're again going to use we're again going to use this power rule here because 16 is equal to 2 to the power of 4. Okay, so now log A of the 16 is just log A of 2 to the power of 4, and that's just 4 times log A 2. Now we've gotten a term that we like. So now we're going to go back to the start, log back to our whole thing, 9a squared over 16 is log A of 9a squared, which is just 2 log A 3, plus 2 minus 4 log A 2. And now we can sub in our expressions for log A2 and log A3, and we just get 2 times log A3, which is 2q, plus 2, minus 4 log A2, which is just 4p. And now we've written the term they want, the expression they want in terms of p and q. Now, this is kind of a long-winded question, but none of the individual steps are too hard. You've just got to remember, use your rules and work step by step, and try not to get flustered by all the work or kind of overwhelmed by it. Just take it one tiny little step at a time, and next thing you know, you'll find yourself at the answer. Or, worst comes to the worst, you get loads of points on the board, and then maybe you get stuck somewhere. But that's okay.